Hey there, welcome to part 4, the final installment of the 6R140 valve body series. And today we're going to put this thing back together for the final time and have it ready to go back onto the case when we get to that point. So got a whole bunch of parts and things on the bench, so I'll just kind of cover everything real quick. First we have our new solenoid set. This is a mix of 4 high and 4 low band solenoids along with a band 3 solenoid. Okay, your band 3 solenoid is your torque motor clutch solenoid. That's normally low. And I have all of the bands and the respective locations written on the lower valve body casting, so make for easy and quick reference. Alright, we have all of our bolts and fasteners, including the solenoid bracket hold down bolts, the 2 bolts that hold the spacer plate onto the upper valve body, and then we have all of our valve body half bolts here. We have our check valves, our 3 accumulator assemblies from the Sonic Zip Kit, our 2/6 feed. We have our pump insert, or inlet rather, our new transmission temperature sensor or temperature switch from Ford. And then we also have the ID tag. I'll mention something trivial but not so trivial about that I haven't mentioned thus far when it comes to this particular transmission. And then we have our feed pipe assembly. And I mentioned this before, but I'll mention it here too in case you didn't watch any of the other videos. For your 4x4 applications and 2-wheel drives that have a flanged output shaft yoke, you're only going to have a pipe system that looks like this. It's just 2 pipes that cross over. If you have a slip yoke design, then where the there's a the drive shaft has a slip yoke on the end of it, you will have a 3-pipe setup, which is this right here. Okay, so these 2 pipes feed low reverse, and then this 3rd pipe actually feeds a lube circuit for the extension housing bushing, where the bushing and the slip yoke kind of mesh together, so to speak. Alright, we also have 2 different seal kits. These came in the overhaul kit for the transmission itself. So here are your feed tubes. And then you have some O-rings. We're going to use a few of these O-rings here. And then here are all your valve body to case seals. Every single one of these parts in here goes to the valve body except for this part here. This little seal is actually your selector shaft seal. That goes on the selector shaft on the transmission. Alright, and as I mentioned, lower and upper valve body casting. And then we have our new spacer plate here still in the box. So this is going to be the updated part number, HC3Z. Okay, and you can see the rest of it. So that's direct from Ford. That is different from the spacer plate that originally came on this unit. And this is the spacer plate here, and the number is HC3P. Okay, so like I said, as long as you have the last 8 digits of the vehicle's VIN number, and you order directly from Ford, you will not have issues or concerns getting the right parts. They'll order exactly what the system tells them to, and there may be a different part number, but don't panic, it is the correct part for the application for this transmission or this valve body or whatever. Alright, what we're going to do first is I want to test my solenoids. Okay, you're probably not going to have all the equipment needed to test these things for full electrical and mechanical function, but most DIYers, I mean, unless of course you're a builder. If you're a builder, you probably have that stuff. But if you're a DIYer and you're looking to kind of do this project on your own, you should have at least a multimeter. And with the multimeter, you can test these for continuity. So I believe you need to be somewhere between 4 and 6 ohms. I already tested these. They're all fine, but we'll walk through that process so you can kind of see it. It's just testing like any other linear or variable force solenoid in any other transmission. But in case you've not done it before, we'll go through the process. And then once I'm satisfied that these are good, then we'll go ahead and actually install them in their respective locations in the lower valve body, because most of the other work, if you will, is going to be done on the upper valve body, including placing most of this stuff in there, and then bolting the spacer plate on. And then the last thing we're going to do is install the transmission fluid pressure switch or sending unit, and then that goes in the lower valve body, and then we're going to put the lower valve body casting, mate it to the upper valve body casting, and install all of the rest of our bolts here. So when we're at that point, all of this stuff you see here on the shop towel will have already been installed. And then I'll just show you where the 2.6 feed and the low reverse feed pipes go. They go in the upper valve body, but I'm not actually going to keep them in there because it's awkward. So meaning like they take up way too much stuff on the bench. I'll just insert them back in when I'm ready to actually bolt the whole assembly onto the case. All right, I'm going to reposition the camera real quick so you can get a better view of the multimeter, and then we'll go ahead and we'll test these solenoids, and I'll very quickly cover banding. Like I said, I'll do a separate video on comprehensively testing these variable force solenoids that you have in this family of transmissions using the specialized equipment that Sonics makes, as well as multimeter and a 12-volt power supply, shop air, etc., so that you can kind of see what that whole process looks like, and from a diagnostic perspective, confirm or deny that solenoids are at the, I guess not the root cause, but the direct cause of a given set of drivability symptoms. All right, we'll go ahead and set up the multimeter. What I'm not going to do in this video is cover the principles or theoretical underpinnings of banding. I mean, that's kind of a whole separate discussion. I will say that your solenoid strategy code that's on the one of the stickers or one of the tags on the outside of your transmission must match that code that is on this tag right here that goes on the valve body. I'll show you where that goes. When I took this off, or took this transmission apart, I saw that this tag was misplaced relative to where it should go, and I'll point that out once we get to that that step in the process. But suffice to say, you want to make sure you have all of your banding with respect to the correct band number in the correct location in the lower valve body for each one of these solenoids, and you don't want to mix and match unless you're willing to reprogram. So like I said, I'm not going to get into the concept of banding or reprogramming. We're going to save that for a separate video. If you want a little bit more information than I'm giving to you right now, check out the 6R80 valve body series. In one of those videos I get into banding a little bit, but like I said, I really haven't given it the proper treatment yet, and I haven't shown you how to actually test these solenoids comprehensively, so that'll be a whole separate video, and we'll do like 6R80 and 6R140. So anyway, you want to make sure you set your multimeter to read in ohms. That's your continuity or your resistance, so to speak, and we're just going to go from left to right testing each one of these solenoids. Okay, and then real quick, I'll flash chart on screen that shows this, but for all your band 4s and band 3s and so forth, you have high band, low band. A high band solenoid is indicated by the black snout, and a low band solenoid is indicated by the brown snout. So we have a 4 high, 2 4 lows, a 4 high, a 3 low, a 4 high, and a 4 low. All right, so that's 5.9. Six. And another thing, continuity will change with ambient temperature as well. So you want to make sure that, if you test these, just be aware that if you had tested them previously and the values changed a little bit, it's probably because the ambient temperature changed a little bit. And that's just something I've noticed over the years of doing this. If it's real hot out, the continuity will be a little higher relative to when it's cooler. So these are new Ford OEM solenoids. I don't expect them to have issues, but you never know. If you get one that's DOA, dead on arrival, you want to know that now so you can order a replacement, send this one back, and versus finding that out when transmission's back in the vehicle and then all of a sudden there's a problem. Okay, so now what we're going to do is go ahead and get the lower valve body over here. See if I can do this in such a manner that I don't have to change the camera angle or move it. Alright. So, like with any other solenoid that takes O-rings, you want to make sure you put plenty of lube You know, you want to be generous, don't be shy, don't be stingy. You don't want to cut an O-ring. Another thing I'll mention is these are also color coded based on the colors of the O-rings. You'll notice the low band solenoids have green and red O-rings, whereas the high band have brown and orange, except for actually not except for counting band 3. I don't know why. I don't know, I was going to tell you except for, they're the same. So just to clear up a misunderstanding I may have just caused, high band, orange and brown O-ring. Low band, brown snout, green and red O-ring. Alright, trash truck's coming, so we got to give it a pause until it passes. Alright, when you install these, you want to make sure that the connectors are face up relative to the casting, which is face down. And then just kind of press firm so that they kind of snap right into place. Alright, if they won't go in at all, then chances are you have, you're trying to put the wrong band, solenoid in the wrong location. So you're trying to put a high band solenoid that in a bore that takes a low band solenoid, and vice versa. And all of the solenoid retention bracket bolts get 97 inch-pounds, and that's true of all of the valve body assembly bolts. So it doesn't matter what they are or how long they are, they get the same amount of bolt torque. So torque's 30, 97 inch-pounds. Just going to get them started, and then we'll zip them in, and then we will torque them up. Alright, if you're going to use an impact, use like a 1/4 inch drive or 3/8 that's low power. I have it on like one of the lowest power settings, so there's no torque sequence on these. You just install them and then run them down and then torque them. I mean, whatever order you want, basically. Out of habit, I tend to go from the inside out when there's a row of bolts like this. But to be clear, that's just my habit. That's not mandatory. Alright, let me get something. I don't want to take a chance on scratching up the worm tracks or whatever, so just gonna use a piece of cardboard that had clutch module in it. All right, so 97 inch-pounds. Like I said, you can do this in whatever order. I like to do it from the inside out. Okay, so a couple things I want to point out before we put this thing aside. Number one, given this is the lower valve body, it's going to have your solenoid strategy and part number ID tag here. So you have a QR code, your solenoid strategy number, and then some other information that you can use to cross-reference parts with Ford. This is supposed to go here like this. And then there's supposed to be a little E-clip that secures it to this little stud or dowel. That was not there when I took this apart. As far as the owner of the vehicle knows, no work's been done on this, but clearly some work has. Somebody's been into the valve body in some way, shape, or form, or has removed it for whatever reason, and I guess they felt the need to remove this, which the only reason you would do that is if you are completely overhauling the valve body. With that said, it didn't look like anybody actually worked on it, simply because when you're doing something with a valve body, at least overhauling it, taking valves out, chances are you're installing corrective parts like a sonic zip kit or a central valve bodies kit or something. And that wasn't what we found when we took this apart in part 1 of this series. So anyway, just an aside, I figured I would show that, or talk about it anyway. The other thing I want to mention is I have all of the valve body assembly to case bolts marked with a red dot, just using a Sharpie. So every other location is going to receive a valve body upper to lower, or lower to upper valve body bolt, but these locations right here, and there's 6 of them. So anyway, like I said, just wanted to make mention of that. Okay, we are going to bring this back to do one other thing before we put it back together completely, and that is to install the transmission temperature sensor. Alright, now I'll go ahead and open up our seal kits so we can get those parts and put them in. We're not going to install any of valve body to case seals until I'm literally ready to bolt the valve body onto the transmission. That's because I don't want to risk screwing them up somehow. Alright, so we have some O-rings here. Like I said, these O-rings are going to be for your conduit tubes and that 2.6 feed tube. For your tube seals, these are all color coded. Now in the 4x4 rebuild kits, they do not have a blue tube seal. So this is the long green one that goes in the rear of the case, and you have 3 identical black ones or unmarked ones that also go in the case. This blue tube seal actually came off of this transmission. This is a 4x4 unit. This is out of that F450 2019, and technically it's not supposed to be there. It's 2-wheel drive only, so I'm not sure whoever was working on this thing before, what they were doing or why, but that tube seal should not have been installed in this transmission. This is something for 2-wheel drive applications that does not come in the 4-wheel drive overhaul kits. And to be clear, these seal kits don't, maybe they're sold separately, I don't know, but they do not come in like the Sonic Zip Kit. And to my knowledge, Transgo does not make anything for these 6R140 transmissions. So I'll take these out just so you can kind of get a gander at them. Okay, these are all valve body, and then this is going to be selector shaft. We'll put that on the other bench. All right, so we'll go ahead and we'll swap these little O-rings. It interesting that they give you 4 O-rings when you really only need 3. And when you're doing this, you do want to be careful. Obviously, you don't want to break the brazing, braze welds there on the mounting flange. That would necessitate that you either re-weld them or replace this thing. And this is also not affiliated with the valve body torque converter seal. Alright, that goes on the end of the input shaft. Alright, now we'll bring the upper valve body over and we'll go ahead and install everything that needs to go into here. So we have 3 check balls here, 1 here, and another here. And we have 2 check valves, 1 here and here. We have our pump inlet feed. That's going to be here. That's a, looks like a cone or dunce cap. And then our 2 spacer plate hold down bolts are going to be in this location right here for one, and another one right here for the other one. Okay, those are the last 2 Torx 30 volts that we need to install. Now these check valves, just make sure they're fully bottomed out with the springs. And then this is going to sit right here. And then let me get that new spacer plate out of its container here. Should have done that already. There it is. So one thing I noticed with these things is that they come, and this is now, I've done several of these, Ford 6-speed transmissions, and all the spacer plates come from Ford ever so slightly curved. I don't want to say bent, but they have a curvature to them. I don't know what the story is with that, but it's been pretty much true for all of them that I've noticed. Alright, so just make sure that you're fully engaged. You got your alignment dowels positioned. There's one here, and then you got one up here. Alright, it's going to be a tight fit, especially on this one. At least it was on this this valve body and plate. Alright, now what we need to do is go ahead and install the temperature sensor in the upper valve body, but first let's get these bolts threaded in. Alright, 97-inch pounds, just like solenoid bolts. We'll need the extension for this. Hey, that was awkward. All right, just double check everything, make sure nothing got messed up, especially if you struggle a little bit with the torquing like I just did. Everything seems to be okay. So you notice here your check bowl location, there is a bathtub. So you're either going to have a bathtub or you're going to have a little orifice. So this check bowl location has an orifice. This has a bathtub, this has an orifice. Alright, so now this thing is ready to receive the the lower valve body. The upper valve body is ready to receive the lower valve body. So we'll bring the lower valve body back. I'm going to lay it down here, and we need to install our temp sensor and our 3 accumulator assemblies. So you have one here, and one right here. I didn't label them, I guess I should have, but make it easier for you to see anyway. So spring's going to go in the little piston, and then the piston's going to go in just like this. It's not recommended that you reuse the factory original accumulator assemblies with those little rubber bumpers, because they do wear over time. This transmission has like 140,000 miles on it, I think. Excuse me. And so, they should be okay at 140, but like, you're up around like 175, 180 or beyond, and you're probably going to start to notice some bumpy shifts. And it all depends too on what kind of life the transmission has lived. Very serious heavy duty or high performance guys with extreme diesel psycho tunes on their trucks, they'll beat the transmissions up pretty good. So all right, so here is going to be where you're going to dock the temperature switch. So all you're going to do is come in like this. This little locking tab stays on the other side. And you're just going to come in and twist and insert just like that. Alright, I probably should have done that before I installed the accumulators, because now if we want to look at it, we're going to have to hold the accumulators in place so they don't fall out. That's what it looks like. So do the switch first, and then the accumulators. I guess I got overzealous, wanted to put them in there. So double check the bench. Make sure that there is no other parts on this bench that belong in one of these 2 assemblies or castings. Okay, other than the feed pipes. They can go in later. Alright. You're going to take your upper, carefully position it over the lower. Notice that you'll have alignment dial locations. Alright, now what you're going to do is just carefully take this whole assembly and flip it over. And whatever you do, don't drop it. Come with it this way. Okay, now we're going to go ahead and install all of our bolts. And I do apologize, I realized I didn't have the long bolts on the bench when we first started this video. And these long bolts go here, here, and here, and here, and I don't know why I spaced it, but I'll make sure to flash a picture much earlier in the video so that you know that you need to have them, but they go here. in these 4 locations. This is the longest bolt that you'll have on the entire transmission. That's going to be that rear filter hold down bolt. But these 4 long bolts have to go in here. You only have 6 valve body to case bolts plus the 2 bolts here that secure the low reverse feed, and then another bolt that secures the 2 6 feed, and they're all of that Torx 30 variety. So again, apologize for any confusion. Just I guess not thinking. Oops, that don't go there. So 26 total upper to lower valve body bolts, or I should say lower to upper valve body bolts. And make sure you thread all of them in prior to zipping them down. And 97 inch-pounds is what they all get. Oops. Just want to throw bolts in locations and don't take them. Doesn't matter that I, indicated or marked it with a Sharpie. I guess I need something a little bit more prominent than that, I suppose. Just double checking, make sure they're all threaded in nice and easy. If anything is kind of bound up or whatever, just stop, pull the lower off the upper and see what's going on. But you shouldn't run into that problem. I mean, these valve bodies are designed to more or less self-align so that when you install all your bolts, they just feed nice and easy. Just threaded nice and easy. Okay, so 97 inch-pounds, and the ATSG manual does not specify a torque sequence. There's no numbered sequence to these valve body half bolts like there are with the 6R80s. At least it's not specified in the manual. I double checked, just online resources and what have you, and I couldn't find anything, no discussion about it on forums or whatever. So with that said, what I like to do is I'll more or less torque them in the same general pattern that you saw me tighten them and zip them down with. So, I'll do kind of like this row here, and then here, and then here, and then maybe here, that bolt here, and that bolt, or something similar. And I'll just go through and check them, column by column, so that I can be sure that I didn't miss any. If I did, I can get it on the check. So I'm going to start with these 3 and then work my way out in more or less a spiral-like pattern. All right, I think I got all of them, but I want to double check. So start here, and then here, and so on and so forth until I hit all of them. And it looks like I didn't hit this one. So that's why I like to check. I have missed bolts in the past, and so the other thing to consider is that the gasket material is still compressing on that first pass, and it may not actually have taken full torque. There was still a little tiny bit of, I guess, air trapped in the gasket itself, so that when you go around on a second pass, you can be sure that you are at true torque. And this principle applies to pretty much any gasket that's, you know, paper or composite. This one right here, I know I torqued that, but it hadn't taken full torque as of yet. And when you're at torque, I mean, it doesn't take much effort at all to get this thing to beep. And that one was not at full torque, so it is now. Okay, just two more to check after this one. And looks like we didn't get to this one either. Or if we did, there was a lot of slack and I had to take up. So that's why I like to do that. I've been doing it for a couple years now, just, you know, what you saw me do there. It helps me catch my mistakes. Alright, this is supposed to go here. I'm going to see if I can find another E-clip that I can use to fasten it. If not, I'll just give it to the customer. It's good to have this tag. I may just give it to him so he can keep it in his glove box, or, you know, where he keeps his registration, license, and all that stuff. Because this way he doesn't have to dig around anywhere to find the solenoid strategy code. So here is your rough forging number. So that's going to be RF. All of these start with that. Yeah, that's going to be the same for every forged part ever made, basically. And then you're going to have your FC3P part number. So this has HC3P, this has FC3P. I mean, I don't know that they're supposed to match. I'll have to check for sure. But this solenoid strategy ID number has to match what's on the tag on the outside of the transmission, and it has to match what's stored in the vehicle's powertrain control module. Okay, all that information needs to be cross-referenced, and when the primary shop takes the vehicle in, one of the, you know, if they're assuming they're working on the transmission, or, you know, taking the transmission out for overhaul, the first thing that he's going to do is cross-reference the numbers that are on the outside of the, you know, in the transmission case where the tags are, with the numbers that are stored in the PCM. He may, as part of his diagnosis, take the pan off and, you know, trying to see if something can be done, you know, short of removing the transmission. So he'll also cross-reference the solenoid strategy ID number that's on that tag. So my tech customer did not have this valve body off. He did take the pan off, but he did not take the valve body off, so who knows. Alright, let me go ahead and lubricate the O-rings on the low reverse and 2.6 feed tubes. And I'll show you where they go real quick. I can get that stable. Okay, so here your low reverse, and here is your 2.6. So this side here is going to face toward the case. And same with this flat side, toward the case. Alright, your third tube will be in this position here if you have a two-wheel drive that takes a slip yoke into the extension housing. Alright, that concludes the valve body series. I guess the only other thing worth mentioning is just noting where your valve body to case seals go. So I'm just bring them over here too. Like I said, wasn't going to install them, but this is kind of the position. So just like that. This big seal goes here. This seal goes in with the top hat itself kind of facing inboard like this. And you have one more that goes like this. Okay. All right. Like I said, that about does it. Maybe I'll just put them in here and just keep them on this cardboard for now. But as always, I really appreciate your viewership. I thank you so much for watching. Hopefully this helped you. You know, if you're working on a 6R140 valve body, you need to do some sort of valve body overhaul, trying to correct some drivability symptoms, or clunky, jerky shifts, missing gears, solenoid issues, maybe get a code for the transmission fluid temperature switch. This series should help you understand how to properly go through and overhaul one of these assemblies from start to finish. So if you're still with me here at the end, part 4, you watched all of them, I really appreciate that. Thank you so much for all the support. As always, guys, if there's anything else you want me to do on a particular transmission, in this case 6R140s, let me know, and I'll go ahead and prioritize it for a video. But for now, that'll do it. Thanks again. Enjoy the rest of your day or evening. I look forward to seeing you on the next video. Until then, take care.